Hello everybody, this is Digital Blackboard by Sachin P. Nagmate. In this video, we are going to discuss the topics Kirchhoff's voltage law and mesh analysis. So let's start. So basically, mesh analysis is the application of Kirchhoff's voltage law and it is used to find unknown currents in a mesh. So first of all, we will discuss about the statement of Kirchhoff's voltage law. So Kirchhoff's voltage law states that in a mesh, summation of all the EMFs plus summation of all the voltage drops is 0. Now Kirchhoff has given us two sign conventions, and according to that, voltage rise is positive and voltage drop is negative. And what is mesh? So basically mesh is a closed path or closed loop. So any closed path or loop is called as a mesh. So let's elaborate it. So according to Kirchhoff's voltage law, in every mesh, summation of all the EMF plus summation of all the voltage drop is 0. So let's consider one mesh or one loop. Now here, three components are connected, that is R, L and C, and an AC voltage source is connected to these components. Now we know that current will flow through this mesh. So let that current is I1. And similarly, if we extend the circuit, then we will be having the second mesh, and in that mesh let the current is I2. So there are two meshes which we can see here. In mesh 1 the current I1 is flowing, and in mesh 2 the current I2 is flowing. Similarly, if we trace the outer path like this, so that is also is called as a mesh, but that mesh is called as outer mesh. So the two meshes which we can see here, this is mesh number 1, it is called as inner mesh, and this is mesh number 2, it is also called as inner mesh. And the third mesh, which is outer, we are stressing the outer path, is called as outer mesh. So Kirchhoff's voltage law we can apply in inner meshes as well as in outer meshes. And the statement remains same, that all the summation of all the EMF plus summation of all the voltage drop is 0. Okay. Now according to the sign convention, voltage rise is positive and voltage drop is negative. Now what is voltage rise? So whenever we apply Kirchhoff's voltage law in any mesh, we trace the path of that particular mesh along with the direction of current. And if in that mesh a voltage source is connected, for example if a battery is connected in a mesh and we are tracing the path along with the direction of current, so if we are moving from negative to positive, it means first of all we are getting negative sign and then we are getting positive sign, so it is called as voltage rise. So this voltage rise has to be taken as positive. Now if we reverse the polarity of battery, and again we are tracing the path in the clockwise direction, so in this battery first of all we are getting positive sign and then we are getting negative sign. It means we are traveling from higher potential to lower potential. So this is called as voltage drop. So voltage rise and voltage drop is possible, both can be possible in a voltage source, that is in EMF. So if we are moving from negative to positive, it is voltage rise, and if we are moving from positive to negative, then it has to be taken as voltage drop, and according to that we have to put the sign. Okay. Now for example, here we can see the battery, this battery is connected between two meshes. It means this battery is common to mesh 1 at this left hand side mesh, and this battery is also common to this right hand side mesh. So for left hand side mesh, if we are tracing the path in the clockwise direction, we are moving from positive to negative, so for that this mesh we are having voltage drop here. But if in the right hand side mesh we trace the path in clockwise direction, then we are moving from negative to positive, then it is voltage rise. So these are some things which we must know for the application of Kirchhoff's voltage law in any mesh. Now let's start with the explanation of the Kirchhoff's voltage law. So according to Kirchhoff's voltage law, we know summation of all the EMF plus summation of all the voltage drop is equal to 0. So we are having here a mesh. So a simple mesh is there in which a battery is connected having value E. Then three resistors are connected, R1, R2 and R3. So but naturally the current will flow in this direction, it means clockwise direction. So in this mesh we can apply Kirchhoff's voltage law. It means in this mesh the summation of EMF plus summation of voltage drop will become 0. So let the current which is flowing in this mesh is I. Now we know that what is voltage drop. So whenever current flows through any resistor, the voltage drop takes place. So here we will be having three voltage drops in R1, in R2 and in R3. And as far as the EMF is concerned, so always with the voltage source which is connected in that particular mesh is nothing but the EMF. So in R1 voltage drop will take place, so it will be a negative sign. Then in R2 again voltage drop will take place, then so we will mark it as a negative. Also in R3 voltage drop will take place, so we will mark that sign according to sign convention as negative. But as far as this battery is concerned, so here we are tracing the path along with the direction of current, which is actual current. So we are moving from negative to positive. It means from lower potential to higher potential. It means in this particular voltage source, in EMF, voltage rise is taking place. So we will put positive sign for this E. So having this much of knowledge, we can apply Kirchhoff's voltage law. So we will be having the equations like this. So in R1, so what is the formula for voltage drop? We know that is I into R. So the formula for voltage drop in R1 is I into R1. Similarly, formula for voltage drop in R2 will be I into R2, and formula for voltage drop in R3 is I into R3. So we are having here three voltage drops, IR1, IR2 and IR3. So we will put negative sign because these are the voltage drop. And as far as E is concerned, we will put positive sign because voltage rise is taking place. So we are getting equation here. So equation will be E minus IR1 minus IR2 minus IR3 is equal to 0. So according to the statement of Kirchhoff's voltage law and sign convention, we got equation E minus IR1 minus IR2 minus IR3. These are the three voltage drops. We have put here negative sign, and in EMF we are getting voltage rise. So here we have put positive sign and it becomes equal to 0. Now if we rearrange this equation, then this equation can be written as E is equal to IR1 plus IR2 plus IR3. Now in the left hand side we are having EMF, and in the right hand side we are having all the voltage drops. So the Kirchhoff's voltage law can also be stated as in a mesh, summation of all the EMF is always equal to summation of all the voltage drop. So this is all about the explanation of Kirchhoff's voltage law. So I hope you understood Kirchhoff's voltage law, how to get the equation by applying Kirchhoff's voltage law and by using sign conventions. Now the voltage law can be verified. We can also verify the Kirchhoff's voltage law if we connect three resistors in series and a voltage source, that is battery, to these three series resistances. Then if we put the switch on, then current will flow. So but natural voltage drops will take place in R1, R2 and R3. So let V1 is the voltage drop in R1, V2 is the voltage drop in R2 and V3 is the voltage drop in R3. So if we measure this voltage drop by using a multimeter, so definitely we will be having the satisfied equation, that is V is equal to V1 plus V2 plus V3, because the total voltage V is getting divided in these three resistors. So it is also application of Kirchhoff's voltage law. So we can verify Kirchhoff's voltage law by designing such circuit. Now if it is okay, if we are having only one mesh, then we have to mark the current in each mesh. So if there is only one mesh, then it is very simple to mark the current to identify the actual direction of current. But if there are more than one meshes available, then it will be very difficult for us to identify the actual direction of current. So the trick which we use here, always assume the currents in each mesh in the clockwise direction, irrespective of the actual direction. So don't bother about the actual direction, just assume current in every mesh in the clockwise direction. So why we are assuming the currents in clockwise direction? Because by doing so, if we are having only one mesh, then it will be simple for us to find out the actual direction. But if we are having so many meshes, number of meshes are there, then it will become very difficult for us to find out the actual direction of current and to mark the actual direction of current. So always assume the direction of current clockwise in each and every mesh and follow the sign conventions, voltage rise and voltage drop in the battery. Okay. So in mesh analysis, we know we have to use Kirchhoff's voltage law, that is summation of EMF plus summation of voltage drops. Okay. So if we are having a mesh here, see, so how many EMFs are there in this particular mesh? So one voltage source means EMF. So we are having only one EMF here, and how many voltage drops will be there? So we are having three elements, components connected. So we will be having three voltage drops. If we extend the circuit like this, then how many voltage drops will be there now? Now there will be total 6 voltage drops. See, again we are having three components added to this network. So we are having here, we are having 6 voltage drops and only one EMF. And if we connect one more voltage source here, so how many EMFs will be there now? Now there will be two EMFs. So always remember, whenever we find resistor, inductor or capacitor, so in these elements always there is voltage drop. And in voltage source, if voltage source is connected in the meshes, then it will be always EMF. And in EMF, that is in voltage sources, the voltage rise and voltage drop both is possible. Both are possible. Okay. So let's take one example, and by solving this example, it will be clear in our mind how to use Kirchhoff's voltage law and how to use mesh analysis. Now see, here the question is find current through all resistor using Kirchhoff's law. So first of all, we will identify the number of meshes here. So we can see here there are two number of inner meshes. So we will forget about the outer mesh. We will just concentrate on the inner mesh. Inner mesh means that mesh in which no further division is possible. So we are having two meshes here. So let's assume the current in each mesh. So let I1 is the current which is flowing in mesh number 1 in the clockwise direction, because we are always going to assume current in the clockwise direction. So I1 is the current flowing in mesh number 1. Similarly, let I2 is the current flowing in mesh number 2. So we are assuming here I2 is the current flowing in mesh number 2 in the clockwise direction. Now we will apply Kirchhoff's voltage law in both mesh 1 and mesh 2. So let's start with application of Kirchhoff's voltage law in mesh 1. So summation of voltage drop is equal to summation of EMF. So we will use this equation. So how many voltage drops will be there in mesh number 1? So we can see we are having 2 ohm resistor connected in mesh number 1. We are having 3 ohm resistor connected in mesh number 1. And we are having 4 ohm resistor connected in mesh number 1. So there will be total 3 voltage drops in mesh 1. Now we know the formula for voltage drops. So formula for voltage drop is I into R. So what is the formula for voltage drop in 2 ohm? So in 2 ohm only I1 is flowing. So but natural 2 into I1 is the voltage drop in 2 ohm resistor. Then what is the current of 3 ohm resistor? So here we can observe that in 3 ohm resistor, the 3 ohm resistor is common to both mesh 1 as well as in mesh 2. So in 3 ohm resistor, according to our assumed currents, two currents are flowing, that is I1 as well as I2. And the direction of both I1 and I2 are opposite to each other, because I1 is flowing from upward to downward side and I2 is flowing from downward to upward side. Okay. So the total current of 3 ohm will be I1 minus I2 or I2 minus I1. But as we are applying Kirchhoff's voltage law in mesh number 1, we will consider I1 is greater than I2. So the total current of 3 ohm will be I1 minus I2. So voltage drop formula for 3 ohm is 3 into I1 minus I2. So always remember the component which is common to both the meshes, then the total current will be the subtraction of two current. So always assume that current greater in that mesh in which we are applying Kirchhoff's voltage law. So 3 into I1 minus I2 is the voltage drop formula for 3 ohm resistor. And in 4 ohm resistor, the formula for voltage drop will be 4 into I1. So these are the summation of all voltage drops. So we have to add these 3 into I1 plus 3 into I1 minus I2 plus 4 into I1. Now there is one EMF also available in mesh number 1. Now in EMF, we know that voltage rise as well as voltage drop, both things are possible. But here we can easily observe that we are moving in the direction of current. So we are moving from negative to positive. We are moving from negative to positive, that is lower potential to higher potential. So in 10 volt, we are having voltage rise. So which sign we will put to 10 volt? Positive. So it's nothing but 10. So according to that, we can easily have the equation, that is 2I1 plus 3I1 minus I2 plus 4I1 is equal to summation of EMF, that is 10. So in the left hand side we are having all the summation of voltage drop, and in right hand side we are having summation of EMF. Now solving this equation, so if we solve the bracket, then 2I1 plus 3I1 minus 3I2 plus 4I1 is equal to 0. Then we can take I1 common. So I1 in the bracket 2 plus 3 plus 4 minus I2 in the bracket 3 is equal to 10. So finally we are getting the equation I1 into 9 minus I2 into 3 is equal to 10. So this is equation number 1. So we got equation number 1 after applying Kirchhoff's voltage law in mesh number 1. Similarly, we can apply Kirchhoff's voltage law in mesh number 2. So if we apply Kirchhoff's voltage law in mesh number 2, then again we are having I1 and I2 flowing in mesh 1 and 2 respectively. So we are having mesh number 2 here. So again we will use the same thing, that is voltage drop. Summation of voltage drop is equal to summation of EMF. Now how many voltage drop will take place in mesh number 2? So we are having 3 resistors here in mesh number 2, that is 4 ohm, then 3 ohm and then 10 ohm. So what will be the formula for 4 ohm voltage drop? So 4 into I2, because I2 current is flowing through 4 ohm resistor. Then what will be the voltage drop across 3 ohm resistor? So again in 3 ohm 2 currents are flowing, but now the total current of 3 ohm will be I2 minus I1, because we are now applying Kirchhoff's voltage law in mesh number 2. So 3 into I2 minus I1 is the total. I2 minus I1 is the total current of 3 ohm. So voltage drop will be 3 into I2 minus I1. Then 10 ohm voltage drop will be, 1 ohm voltage drop will be 1 into I2. Now these 3 voltage drops are there, so we are going to add these 3 voltage drops, and there is one EMF also connected in mesh number 2 of 12 volt. But what will be the sign of this EMF now? So now in EMF, voltage rise as well as voltage drop, both the things are possible. So here we are moving from positive to negative. It means we are moving from higher potential to lower potential. So here we have to take voltage drop. So in this 12 volt, voltage drop is taking place, and for voltage drop according to sign convention we have to take negative sign. So that's why minus 12 will here. So finally we will get the equation 4I2 plus 3I2 minus I1 plus 2I1 is equal to minus 10. So why minus 12? Because here we are having, in this EMF, in this voltage source, we are having voltage drop, because we are moving from positive to negative. Again, if we solve the bracket, then 4I1 plus 3I2 minus 3I1 plus 1I2 is equal to minus 12. So finally taking I1 and I2 common, so we are getting equation number 2, that is minus I1 into 3 plus I2 into 8 is equal to minus 12. So we got two equations after applying Kirchhoff's voltage law in both the meshes, both the inner meshes. So we are having equation number 1 and then we are having equation number 2. So how to obtain the equation is very important. Obtaining the equation is nothing but Kirchhoff's voltage law. So we have got two equations, equation 1 and 2. And if we solve these two equations simultaneously, then we can get I1 is equal to 0.698 ampere, I2 is equal to 1.238 ampere. So now you must be worrying that the I2 current is negative, that is minus 1.238. But current cannot be negative because current is a physical quantity. So why we are getting minus sign for this I2? So this minus sign indicates that our assumed current, our assumed direction of I2 is exactly opposite to that of actual direction. It means we have assumed I2's direction in mesh number 2 in the clockwise direction, but actually the current is flowing in anti-clockwise direction, and that's why negative sign is appearing there. So don't worry about the negative sign. Negative sign just indicate that our assumed direction, because I1 and I2 are our assumed currents, not actual current. We never check for the actual current. Don't check for the actual current, always assume the current in the clockwise direction, and if negative sign appears, then it indicates that our assumed direction of current is opposite to that of actual. So that's why I2 is minus 1.238, but we know current cannot be negative, so we will put I2 is equal to only 1.238 ampere. So current is always positive, so I2 is equal to 1.238 ampere. So only the sign will change if our assumed direction is opposite to that of actual direction, so only sign will get changed, but the magnitude of that current will remain same. So we got I1 and I2 here. So what will be the total current of 3 ohm now? So total current of 3 ohm will be I2 minus I1, that is 1.238 minus 0.698. What will be what is the current of 2 ohm now? So we know only I1 is flowing from 2 ohm, so the 2 ohm current will be 0.698. Similarly, the current of 4 ohm will be also 0.698. The current of 3 ohm is 0.54 ampere. Now current of this 4 ohm will be 1.238 ampere, and current of this 1 ohm will be 1.238 ampere. So we got currents through all the resistors by using Kirchhoff's voltage law. So I hope you got better understanding about how to use Kirchhoff's voltage law. So it is very easy tricks which we are using here. No need to mark the potential difference plus minus for every resistor. Just assume the current in the clockwise direction and all voltage drop is equal to all summation of all the voltage drop is equal to summation of all the EMF. If we do this thing, then we can get the correct answer for any problem for any complicated network. So points to be remembered: always assume the currents in individual mesh in clockwise direction. In components, that is resistor, inductor and capacitor, there is a voltage drops, and in EMF, that is voltage source, there can be voltage rise or drop. If moving from positive to negative, then it's drop, and if moving from negative to positive, then it's rise. So in next video, we will continue this topic and we will discuss mesh analysis in the AC circuit. So I hope you understood this topic very well. So please like, share and subscribe Digital Blackboard. And for any query, you can contact Sachin Nagmote at gmail.com. Thank you very much.